All right, so we're doing the ACT 2018, the June one. We're going to do 1 through 15 here. So Schwann sold 9 used books for $9.80 each. With the money from these sales, she bought 4 new books and had 30 left over. 37.80 left over. What was the average amount Schwann paid for each new book? Wow, okay. So she sold 9 used books for 9 times 980. So that's how much money she had. And then she bought 4 new books. But when she bought the 4 new books, she still had 37.80. So to get how much she spent on those 4 new books, we're going to subtract 37.80 from that. So whatever that is, we're just going to use the calculator at the end, but that's how much total she spent on the new books, and she bought 4 of them. So to get the average price, we're going to have to divide that by 4. And then we'll just type that into the calculator. The ACT is not shy about making you use the calculator like the SAT is. So 9 times 9.8 minus 37.8. I'll just hit enter and then divide it by 4. So 1260 was the average price she paid for the new books. All right. A point at negative 5, 7 in the standard coordinate plane is translated to the right 7 coordinates and down 5 coordinates. Okay. So they just down 5, so that's the y value is down. So they subtracted 5 from the y value into the right 7, so that's positive on the x. So they added 7 to the x. So it's actually now at positive 2, positive 2. Okay. That's fine. All right. Chantil left her home at 9 a.m. on Tuesday and traveled 648 miles. When she arrived at her destination, it was 3 a.m. the next day. Wow. Given that her home and her destination are in the same time zone, nice. Which of the following is closest to her average speed in miles per hour for this trip? All right, so we just want miles per hour. So we're just going to do the 648 miles divided by, and you got to count how many hours. So the ridiculous 12-hour stuff. So, or we could say 9 a.m. to 3 a.m. Well, 3 to 9 is 6 hours. So a whole day is 24 hours, and she was 6 hours less than that, so it took her 18 hours. So 648 over 18. And we'll just calculate that. 648 over 18. 36. And that makes sense. It's not going to be like 70 because she's not on highways the whole time. She's going to have to go through some city. So 36 miles per hour makes sense. All right. The text message component of each of Juan's monthly phone bills consists of $10 for the first 300 text messages sent that month, and then 10 cents for each additional after that. Oh, that's expensive. On Juan's most recent phone bill, he was charged $16.50 for text messages. How many text messages in total did he make this month? Okay, so he was charged over $10. So that means he sent the 300 texts for the $10. But then he was charged an extra $6.50 on top of that. And so if you divide that by 10 cents, don't need a calculator for that. That's 65 texts. So we sent 65 extra texts. So the 300 for the original $10 and then 65 more. So 365. Cool. All right, 5. So matrices. A lot of people are unfamiliar with matrices that might be taking the ACT. But this is an easy thing to do with matrices. When you're adding matrices, you just add all the corresponding components. So you go like 9 added to negative 6 is a positive 3. So that spot's got to be a positive 3. So you cross out all of those. And then look at what's different. This is the only one that's different. So go to that next. Negative 4 plus 5 is a positive 1. So it's A. Then, of course, you see the 8 plus 6 is the 14, and the 7 plus 4 is the 11. But it's nice to focus on what's different, so you don't have to calculate everything. All right, next. A function is defined by that. Whoa, okay. So this isn't notation we're used to, but see how it's the same thing. It's just you have your x and your y. So here they're saying that the x is 4, and the y is 3. So that's 3 times 4 squared, 48, minus 12, so 36. So this is just like 3 dimensions. So that would be like the z or something. But we don't care exactly what variable, it's just the function itself. All right, a certain group consists of 5 children, three of whom are age 10. Oh, three of whom are age 10 and two of whom are age 5. What is the mean age of the group? Okay, so we'll just add them all together. So we have three of them that are 10. So 10 plus 10 plus 10 is 30. Two of them that are 5. 5 plus 5 is another 10. Not times, but plus another 10. So obviously 40. But then we're going to divide that by 5 children. So that's going to be 8. I didn't need a calculator there at all. All right, so in the figure below, they're parallel. Yeah, so when you have something like this and you know that these are parallel, that's an important thing to know, that these triangles are going to be similar then, because that's going to mean all your angles are going to be equal in these two triangles. So we can use similar triangle things. And nicely they label stuff for us. So what do we want? We want DE. Well, let's see, what else do they tell us? BD equals AD. Oh, okay. That's interesting. Okay. So if that's x and that's x, this whole thing is 2x. So, oh, wait. How am I going to use that 10? I mean, I can use that 10 to find that entire height, because that's going to be 4. Or I guess no, I can use that to find this height. What do I even want? I want DE. I mean, I don't think that height's going to be half. Oh, or is it? Yeah, this is half of this entire thing. So then this is half of this entire thing. So that's just got to be 4 then. Okay, yeah, that's just a similar triangle idea. You see that those are similar. So then you say that, like, x is to this y as that 2x is to 8. So, right, so that's canceling out, and so you get x over y equals x over 4. So y has to be 4. Okay, that makes sense. That makes sense. All right, number 9. In a poll of 500 registered voters, 337 voters favored a proposal to increase funding for local schools. Suppose the poll is indicative of how the 22,000 registered voters will vote on the proposal. Which of the following values is closest to how many of the 22,000? So there's an SAT question like this too. You just have to multiply by the percentage. So I guess I would just do that. I would calculate the percentage. Or you can set it up, it's like a proportion too. The 337 out of 500. So x out of 22,000. And so see, all you're going to end up doing here is the 37 divided by 500, whatever that decimal is, and then you're going to multiply that. Whoops. You're going to multiply that by 22,000. So 14,828. And it's probably which is closest. Oh, just round a little bit. There we go. All right, Diego purchased a car that had a purchase price of $13,400, which included all the costs and tax. He paid $400 as a down payment and got a loan for the rest of the purchase price. So that's a big loan. Diego paid off the loan by making 48 payments of $300 each. The total of all of his payments, including the down payment, was how much more than the car's purchase price? All right, that's a cool question. So how much in total did he pay? Well, he paid $300, and he did it 48 times, but he also paid the original 400. So 300 times 48 plus 400. So we paid a total of 14,800. Okay, right. So that's the total amount he paid. The car was only worth 13,400. So if you do that answer minus that, you end up with 1,400. So that's the difference. So that's a pretty good deal, especially with such a low down payment. All right, in the standard coordinate plane, what's the slope? So if you wanted the slope of the line, you just put it in y equals mx plus b form, which basically means solving for y. So see how you're going to subtract that to the other side. So it's going to be a negative 7y. So then you got to divide by negative 7. And so there's your m. There's your slope. You don't even care what the y-intercept is. So like if you wanted to really do it, you'd have to subtract the 9 as well, and then divide that by negative 7 as well. But we don't care about the y-intercept. We just care about the slope. Okay, so all these lines intersect each other. That's perpendicular. It says all this on the graph. So given that the measure of that is 25, which is also on the graph, what is the measure of BCD, which is the question mark on the graph? All right, that's pretty easy because vertical angles, if that's 25, then that has to be 25. And you know the triangles add up to 180, so we got the calculator open anyway. So we'll do 180 minus the right angle, so minus 90, minus the 25 that we just saw. So this angle is 65. And then this is a straight line. So remember, straight lines are always 180. So to get what BCD is, we're going to do 180 minus that 65. So that's 115. Nice. All right, this is good. What is the sum of the two solutions? So this is the trick that you can solve this easily enough. But the sum of the two solutions is always negative b over a. So you can just look at this and see that the sum of the solutions is negative 1. And notice what that comes from. That comes from the fact that what do you think about when you factor? We would think about what multiplies to negative 30 and adds to 1. So right there, there's our sum, adds to 1. But then the reason it's negative is because now what are the solutions? The opposite signs of those. So that's why you can see you add those together and you do indeed get the negative 1. All right. The volume of a sphere, they tell us, that's a little lame, is that. What is the volume? So with the diameter of that? Well, the diameter is 4. That just means the radius is 2. So we're just going to go 4 pi 2 cubed over 3, which is 2 to the 5th over 3, which is 32 pi over 3. So that's F. All right, nice and easy. One more. What is the smallest integer greater than that? So we just got to round up to the next perfect square. So 81 would be rounding down, and that's 9 squared. So the next one would have to be the square root of 100. So 10. So when I always estimate these, that's how I think about it. I think about the square root of 85 is bigger than the square root of 81, but less than the square root of 100, right? So that means that the square root of 85 is between 9 and 10. And that's all we got for today. That was a nice, quick, and easy one. First 15 are always easier than the last ones. But we'll come back tomorrow for more ACT.